How would you quantify the idea of roughness? Seems tricky, but to help us we can use something called fractal dimension. That is, dimensions with non-integer values.
Wait, non-integers?
Yeah, it's kinda weird when you first think about it because when describing dimension, usually it only makes sense to have integer values. But here's another way to describe it. So here I have three shapes with their respective dimensions. If I double their size and count the number of copies of the original versions needed to make the new ones, you can see that the new line needs 2 copies of its original, the square needs 4 copies, and the cube needs 8. And we can see a pattern here. In general, if you scale the object s times bigger, the object is equal to s to the d power copies of itself, where d is the object's dimension. So in the case of the symmetric triangle, if we double its size, it's going to equal to 3 copies of itself. So solving for d will give us that its fractal is about 1.585 dimensional. And using the same method, we can find the fractal dimensions for other self-similar fractals as well. And these values give us information about how rough they are. And the higher the value is, the rougher that object becomes. And not just for self-similar fractals, but we can also find the fractal dimension for any rough, jaggy things in real life. So although it may seem like nonsense, fractal dimension is a very useful tool to describe roughness in many fields, including the field.